Hi class, I'm gonna discuss today's section 1.2 applications of linear equations. This is on page 63 in the book. Um, okay, here we're going to discuss break-even analysis, uh, depreciation, piecewise linear graphs, and some calculator tips too. Okay, in here, uh, I should tell you many real processes are modeled by linear equations, though they are really not. You know what I mean? Uh, many real processes are not linear functions, but here we consider those real processes modeled by linear equations. Uh, Here we're going to discuss some examples from business. A simplest description of production cost as a linear function of number of items sold is this. Uh, Suppose a manufacturer has a fixed overhead cost. You know what overhead cost means? That's the fixed cost uh, initially that he has to bear due to maybe machinery, maybe electricity, etc. um, the rent, likewise the fixed cost, fixed overhead cost of $D. I write those symbols. Overhead $D per month. Cost of producing each of a particular item is M dollars. Cost per item, or you can say unit cost. This is per month. What else? The assembling line produces X items per month. X is number of items. We give letter to each thing, so we can make a formula using these letters. Then the total monthly cost is C is given by, okay, C is what? Total cost. Again, this is per month. Cost per item in business, there is a term using for this. This is also called marginal cost. Okay. Then this is how we calculate total cost. C, total cost first of all consists of, uh, if you know the cost per item and number of items producing, cost per x number of items, we can say it is m times x. This gives us cost to produce x number of items. X is the number of items, m is cost per item. Now when you calculate total cost, we have to add this to the overhead. Means, for example, I said the rent of the place, etc. So I have to add the overhead to that. Rent of the place, initially has to install machinery, etc. That all goes to the overhead. So this is his cost, total cost. Okay, now where he get income? For income, it's called revenue. I write down these new terms for you separately. R stands for the revenue. This is like income. This is again per month. Now revenue means how we get the income by selling these items. For that we have to decide a price, right? It is not cost per item, it is different price. We have to decide. It has to be definitely more than cost per item, otherwise you don't make money. In fact, you lose money if the price is less than or equal to the cost of producing that particular item. So price, there are various factors to decide price. I write simple P for price. Price of an item. So with this we can write the revenue. Revenue means total income is given by, if you selling X number of items and the price is simple P, therefore it is simple P times X. I write simple P like this. We need to have another P, that is for the profit. I use capital P for the profit. Okay, let's see how we calculate the profit then. So we get another letter. This is the for the time this is the last letter I'm introducing capital P. This stands for the profit. So after that I write the profit equation. How we calculate the profit? Profit is your total income minus expenses. Total income is revenue, which is R, minus your total expenses is this total cost, which is capital C. Okay. R is what? Price times number of items minus cost is mx plus d. So that is the cost. I have to write that in parentheses. I'm gonna erase this. So you get, simplifying this, we get simple P minus M times X plus D for the profit. This is the profit equation. Okay. Now let's see graphs of these three: cost, revenue and profit. Especially cost and revenue, let's see first on the same graph. I'm gonna erase this. This is X, number of items. Okay, if you do revenue on y-axis, initially it has overhead. If you remember the revenue equation, let's do cost equation first. Cost equation is what? Cost equal to M times X plus D. Cost per item times number of items plus the overhead. So initially this cost function has D, overhead value, means when X equal to 0, even when you sell no items, it still has D. It starts with D. Then as you supply more and more items, your cost increasing. So it goes like this. That is the cost function. Let's do the revenue also on the same graph. I use a different color for that. Revenue is what? revenue equals to price times number of items. So here there is no intercept, but if you sell no items, you get zero revenue, means you make nothing. Therefore it starts at zero. When you start selling items, it is increasing depending on your price, right? So I told you price should be more than M. M is the cost per item. Therefore the graph of this is steeper than graph of cost, because the price should be greater than M. Therefore that graph starts from here and it goes it should be steeper than the cost graph. So what is this one? This is the revenue graph. I write it here, R equals P times X. This is this, and this is this. Okay. Now you see these two graphs intersect right here. So what happened here? At this point you see revenue, this shows you the height to the graph. R means height from x-axis to the blue graph. C means height from x-axis to the black graph. Those heights are equal here. That means at this point R equals C. That is a special point. At this point R equal to C. That means your whole income is going to the cost and you make nothing. I erase this. Write P greater than M here. This implies when R equal to C means you make nothing. That means your what's your profit? Profit equals to 0. And this point has a special name. It is called the break-even point. It's called the break-even point. Okay, now let's see what profit function looks like. Now what's profit? Profit equal to revenue minus cost. So before this break-even point, R is here, C is here. Therefore R minus C, R is smaller than C, therefore R minus C should be negative. it starts from the negative region. And what happened here? It's going to 0. It starts negative and it's going to 0. After that, revenue is more than cost, therefore it is positive. Therefore the graph should be like this. Let's get this break-even point. At the break-even point, it is 0. It should go this point. Should go through this point. And this is the break-even point. This is X and this is profit. Here simple P, here capital P, profit. So this is the profit equation. P equals to what we found before, P minus M times X minus D. Okay. You see at break-even point, the profit is 0. Okay, let's see an example. Okay, I'm gonna erase this. Example 1. This is from book, page 63. It is on page 63. I'm going to read the question. A pharmaceutical company spends $40 million on $40 million on equipment, that is D, the overhead, on equipment needed to produce a new drug. It then spends $2 million on raw materials for each million units of the new drug produced. Okay. To number of this is also in millions. So total cost, even number of units is 0. It's 40 for equipment. That's the overhead. Even when this is 0, this is the total cost is 40. Now let's read this. It then spent 2 million on raw materials for each million units. That means, okay, for each million unit it spent 2 million. When it said spent 2 million here, this 40 will become 42. That is 42 million to produce what? How many millions of units it's producing? 2. For each million, for each million to produce 1 million of unit, it's spending 2 million. 2 million plus this 40 is 42. To produce another million unit, say 2 million, they have to spend another 2 million here. So 42 plus 2 is 44. Another million, that means 3 million units. You have to spend another 2 million here. 46. 4, you have to add another 2 here. 48. Right? Likewise, now you can write more numbers here, but what really book is showing you is this. After this, it does not show you this part 1, 2, 3. The idea is the book wants to show you little bit far away points. This point, it wants to show you this point, this point. After that, we can calculate if it is 8, then this should be 56. Means from 4 to 8, 5, 6, 7, 8, 4 million units. For each 1 million, they spend 2 million. Then 4 times 2 is 8. 48 plus 8 is 56. That's how they get this number. Likewise, 12, 64, 16, 16 and 72. I don't have enough space here on this side, so I write those numbers here. 20, 80. You don't need that many numbers. In book, as I said, they do not show you this part. They show you this, and after that these points, 16 and 20. Okay. The number of units produced monthly range from 0 to 20 million. Make a table showing the relationship between the number of million units produced N and the cost C. This is N and this is C. Okay. To produce the number of million units. Okay. So this is the table. That means this is part A. Part B, find a formula that expresses C in terms of D, C in terms of N. What's the cost formula? Cost formula is M times X plus D. M is what? M is cost per 1 unit. For 1 million unit, for 1 million unit, they spend 2 million. That means, forget about million story. To produce 1, they spend 2. Therefore, M should be 2. What's D? D is the overhead. When producing 0 items, they still have to bear this expense, $40 million. Therefore, D is 40. Substituting, we get C equals, here X equal to what? X number of items. They said it is N. X is N. Therefore, it is 2 times N plus 40. Right? That's it. Find the formula that expresses C in terms of N. So this is the formula. Okay, let's do another example. I'm gonna erase this. Example 2, page 65. BBC Wineries has a fixed monthly overhead $2,000 and a cost of $20 per bottle to make and bottle wine. That means D equals, I hope all you guys have the book. If I'm going to write the question, it takes a lot of time here, so please keep your book handy. Read the question. It is on page 65, example 2. D is 2000, the overhead, and cost of $20 per bottle. That means M. M equals 20. The wine sells for $30 per bottle. Wine sells. Selling means the price. Price is 30. Part A, find the cost and revenue equations and a break-even point. Part A. cost and revenue equation. Cost equation is what? C equals mx plus d substitute values, we get C equals m is 20, x plus d is 2000. That's the cost equation. Revenue equation is what? Price times number of items. Price is what? 30. Therefore it is R equals 30x it's also asking for the break-even point. For break-even, what's the condition? Revenue should be equal to the cost. Revenue is given by 30x, cost is 20x plus 2000. This gives us 30 minus 20 is 10x equal to 2000 and x equal to 200. That means break-even point equal to 200 means when the sales is 200 bottles per month, the winery is break-even. That means they don't make money, they don't lose money either. So at this point, when x is 200, we have this revenue and cost both the same. We can find what it is by substituting this 200 in one of these two equations. For the convenience, let's substitute it for the revenue equation. Where can I write it? I write it here. When x equals to 200, using the revenue equation, R equals 30x, 30 times 200, this is equal to 6000. Then learn how to express the answer. Therefore, the break-even point it's a point, so we have to give coordinates. X coordinate is 200, y coordinate is 6000, equal to 200 comma 6000. Okay. This is the break-even point. Part B. Find the profit equation. I'm gonna erase this part A. How we get the profit? Profit equal to revenue minus cost. Revenue we found 30x minus cost we found 20x plus 2000. This is 10x minus 2000. Okay, that is part B, profit equation. Part C, how large must sales be in order to achieve a profit of 1500 per month? That means find X when P is 1500. Substitute it here. P is 1500 equal to 10x minus 2000. This gives us 10x equal to 3500 or 3500, and x equal to 350. Okay, that means to make profit of $1500, they have to sell 350 bottles. Okay, let's see another example. I'm gonna erase this. Okay, example 3 on page 67. Okay, this question is from depreciation. Okay, example 3 on page 67. Miss Winslow buys a new car. A lady buys a new car for her business for $13,000. She expects to use the car for 5 years and then sell it to a used car dealer for $2,000. That means $13,000 worth of car at the beginning. After 5 years, it will go down to 2,000. Find the equation for A that describes the value of the car after T years. If she uses straight line depreciation. Okay. At the beginning, that means when t equal to 0, value of the car they ask us to take it as A is 13,000. After 5 years, it is 2,000. Okay. So we can nothing to worry about this question. We can use the simple technique that we used under equation of line, assuming we get 2 points, 0, 13,000 and this. Just use these two as coordinates of 2 points. So this is like x1, y1, this is x2 and this is y2. Right? Assuming that if you write the slope, what's the slope equation? Slope equation is y2 minus y1 divided by x2 minus x1 2,000 minus 13,000 divided by x2 minus x1 5 minus 0. Negative 2,200. Now m is this. Now usually we use y minus y1 equals m times x minus x1, the point slope formula. To write the equation of line, but in this case we don't have to use this, right? In this case we can directly substitute in y equals mx plus b form. Y, it is given when x value is 0, it is 13,000. That means its y-intercept is 13,000. B is 13,000. m is this negative 2200. Substituting, we get y equals to negative 2200 plus 13,000. Okay, now one thing, they ask us to use this y value as a, therefore this should be a. Right? We plug it here, we get this answer. This is the equation. Okay, this is example 3. Okay, let's do an example from piecewise linear graph. I'm gonna erase this. Piecewise linear graph. Okay, let's do this example number. Oh, it's not an example. Okay, practice question. It is on page 68. Okay, this is given by y equal to 2x 2 negative x plus 5. Okay, now piecewise function means one function one function y is given as three pieces. See, this one function, it gives as three pieces. It looks like three equations, but what happened is, uh, in this region it behaves like this, in this region it behaves like this, in this region it behaves like this. uh, when we do piecewise functions, sometimes in place of y we use function notation, we write fx. So if you see this instead of y, uh, it is understand it's the same thing, right? Okay, now again, these regions x less than 1, if you write this in, you don't have to write this in interval notation, but if you write this, this is same as negative infinity to 1, this side it is parentheses, this side it is bracket. This is 1 2 3, 1 2 3, 3 in bracket, 1 in parentheses, greater than 3. This we can write as 3 to infinity, both sides parentheses, no bracket, parentheses. Okay, now if we do this graph, so it has three parts. So we have to mark 1 3 0, say 1 here, 2 3, we don't need other numbers, 4 4 5 6, we have them here. This is the x-axis, this is the y-axis. From negative infinity of x to 1, it behaves like 2x. Y equals 2x is a straight line with positive slope, go through 0 0 point, because y-intercept is 0. Before we draw, we have to find out what's the value of this when x equal to 1. When x equal to 1, it is 2. So that point is included because this says x less than or equal to 1. It should come to this point. Right after that, next piece I'm gonna draw with a different color. One, 2, 3. It behaves like this. When doing this, be careful. This does not depend on x. Whatever the value, it stays 2. So it goes up to 3. Point 3 is included. Even at when x equal to 3, the value is the same, it is 2. Here that point is included to the second part. So when x equal to 1, it's still 2, therefore we continue from here to there. You shouldn't color this in green, because 1 less than only, no equal, therefore you should not shade this in green. This shaded already in black. The third part, negative x plus 5. Negative x plus 5, it has a negative slope when when x equal to 3, when x equal to positive 3, this will become negative 3 plus 5, which is positive 2. So we can start at this point. We start at 2. I use a different color. Use blue color here, and it has a negative slope. Let's see what happens where it's crossing y-axis. When it's crossing y-axis, I mean x-axis, its y coordinate is 0. If you set this to 0, negative x plus 5 equal to 0, x equal to 5. That means it should go through this point, greater than 3. So it will continue to go like this. So this end it is like this, this end it is like this. I want you to pay attention especially to these 2 points. I shaded this in black, I shaded this in green, I shaded nothing in blue. Understand why, right? I shaded means that point is included, that's where it has equal sign, right? In third part it has no equal sign, therefore no shade in blue color. Okay, that's it. Okay, let's see. Let's see you calculate the tips. Okay, I'm gonna erase this. Let's use example 4 to discuss this. Page 69. They give us a table. This is in example 4, the 2003 schedule X is used by single taxpayer to determine their tax. Table 3 portion of the schedule, of this schedule. Okay. Using that schedule, we can write a piecewise function for the text t. Okay. Let's write the text function. Okay, this is I give you calculator tips. For that I use example 4 in page 69. So the text function is given by this. Using the table they give you in page 68. In fact, this example in page 68. Zero point 1 x if 0 less than x less than or equal to 7000, 0.15 x minus 7000 plus 700 if 7000 less than x less than or equal to 28,400. Okay, using table we can write this text function t like this. Okay, now uh, the what I'm trying to tell you here is uh, not about writing this but how to do the graph uh, using the calculator TI 89. Now go to turn on your calculator. This is calculator. Press green diamond and F1. This gives you graph in menu, the y equals, right there. You type like this, you will see y1 equal to y2 equal to blah blah blah, right? So there okay, I write a couple of them. You type the equation, this 0.1x. okay, what you type in, I typed in a different color. Calculator give you these y1 y2 y3 y4 y5 whatever it is. It gives you whole bunch of numbers. Then you type 0.1x. You know how to type this. Just type numbers. And this one, this is the thing I want to show you. To enter that, there is a straight line, vertical line. Is the in your calculator. Let me see if I can show you that. I don't know if it is clear to you. You can find it out. It is right below equal sign. Equal sign is here. Right below equal sign you have vertical line. That after that you enter the condition, this condition 0 less than x and x less than or equal to. You can type this one, you can do it in two ways: less than, equal 7000. Also, if you like, you can do less than or equal this part as you can use again green diamond and 0. This gives you less than or equal to sign, like that. Okay, even if you type less than and equal sign, that's fine, it works. What else? Likewise, you enter these four. I'll enter one more, 0.15 minus 7,000. 700 vertical line, 7,000 less than x, and x less than or equal to x. I'm gonna use this thing here now, green diamond. I write it in green because it's the green diamond. Green diamond exactly like this. Green diamond 0. This is green diamond, and number 0 gives you this less than or equal to sign. $28,400. $28,400. Okay, likewise you enter all these equations, then enter green diamond and F3. After you enter all these, then you hit, so you have to enter 4 equations up to here. Then you enter green diamond and green diamond and F3, green diamond F3. I don't know if you can see it, but you know where it is. In last lesson, last video, I explained that these functions, green diamond and F3, to graph. This is to graph. Okay, what else? Okay, one other thing, when you do this and hit the green diamond and F3, sometimes you may not see the graph. That's because it is out of the scale, because these numbers are big. So what you can do is you can zoom it. You go to window, that one. Now this is how you graph. That part is done. Then I'm gonna teach you how to zoom the calculator a little bit. I'm gonna erase this. To zoom, use window. Window screen. Let me see what it is. It is it is green diamond and F2, right? Green diamond and F2, it gives you a zoom screen. Or you can use straight F2. F2 followed by zoom box. This or F2, then choice number 1, zoom box. Okay, zoom box. Okay, once you do that, you can adjust x minimum, maximum, y minimum, y maximum values. Now for this particular example, give some big values for x maximum, because x values were pretty big. You had 7,000, 28,000, or 143,500. So to get these values, you have to adjust this zoom or zoom window. So set these values like this. X min, you can set it to 0, no problem, but X max, set it to a big value. I set it to 100,000. SCL, this means X scale. X scale, set it to 2500. This is not a must, you can try different values. Y min, equal to 0. Y max, $25,000. Y scale 500. X RES. RES stand for resolution. It doesn't matter actually. Leave it to, right? It doesn't matter. X resolution. Now set these values and click on what is it, green. Set this window, and after that graph it again using green diamond and F3. Okay,